We're going to work on probability and the distribution based on a normal distribution. You're going to need your unit normal table, which is located at the back of your textbook, table B.1 in the appendix. And you're going to need this to be able to walk through this and find proportions as well as z-scores. So we'll start out with this population study with memory recall scores with a mean of 12, a population mean of 12, and a population mean of 2.3. The first question is, what is the minimum score needed to be in the top 10%? The first thing you should always do when there is a probability question and a distribution is you should be drawing it before you do any math. So immediately, right away, I'm going to draw a distribution. Now it doesn't have to be perfect, but the purpose of this is so you can locate the mean and try to figure out where things are located. There isn't an exact, you don't need to put every deviation on the x-axis. What we really want to do is just locate the basics. So the first thing I do is I locate the mean. So we know the mean equals 12. So we know right here is a score of 12 at the mean. Now they're looking specifically for a minimum score in the top 10%. So we know the top 10 is over here. So we're going to be looking at any score. The scores that fall over here make up 10%. But what we want is the minimum score. So what we're looking for really is the score that falls right here. So x equals, we don't know. We don't know what that is. But we do know that this is 10%. And we don't have it shaded a perfect 10%. It doesn't matter. It's just an estimate. We know that 10% equals P equals 0.10 because we'll move the decimal over 2 places to the left to get our proportion. Now, to be able to get the score, we're going to need our z. So we're going to need to use our proportion, our p value that we just figured out, p equals 0.10. This is when you're going to look in that unit normal table. Now, in the unit normal table, you're going to look up 0.10 in column B, the area, in column C. I'm going to remind you, in column C, the area beyond Z in the tail, because this is the tail. So we're going to look in column C. Okay, I'm going to put a C here. You're going to look up 0.10. Get the closest that you possibly can to 0.10. Now be very careful of your decimals. It's 0.10, not 0.01. It's 0.10. So you have to be real careful. And I used 0.1003. I figured that's the closest. And I move over to find a z-score. So that's what I'm looking for, is a z-score. Now z equals 1.28. Now we know that's a positive because we're looking at the right hand side of the mean, the upper area, the top 10%. Once we have that z-score, we can find our score, our minimum score. So we're actually going to use the z transformation, but we're going to use, in actuality, the raw score equation, which is x equals mu plus z times standard deviation. It works just the same if you use the z transformation equation. You just have a couple extra steps. So we're going to find x now. So we have everything we need. So x equals, we can plug in 12 plus, I'm going to put 1.28 and our standard deviation of 2.3. If we calculate that out, our x should equal 14.94. So this is the final answer. Or if you really want to be technical, the minimum score needed to be in the top 10%, x needs to be greater than or equal to 14.94 to be in the top 10%. So that's the first type of question you'll see. So using proportion to find z to find a raw score. You can't find a raw score without having a z, so you have to use that proportion and kind of go backwards. So let's try another one related to the memory recall scores. Next one we have it as far as question is, what is the percentile rank for a score of 13? Again, the first thing that I want to do is draw my distribution and locate the information. So we know the mean. First thing I do is put the mean, which is 12. Mu equals 12. Then I can see immediately, okay, my score is 13. So that's going to be above the mean because the scores get bigger as you go to the right. So we know we're just going to put like a line here and say 13 goes here. Okay, that's what we're looking for, is that location. So we're going to need to find z at that location. Now it doesn't matter, you don't have to have it perfect as far as how far it is from the mean. It's really just, is it above the mean, is it below the mean, is this making sense? So the next thing I want to do is look at, okay, we're looking for percentile rank. Percentile rank means everything below a score. So in this case, we are literally looking for everything below a score of 13. And remember here, at this point is the 50th percentile at the mean. So we know everything over here is 50%. Or P equals 0.50. So we already have that proportion. Now we just really, the key is we need to find this sliver of a proportion right here is what we need. So the first thing we need to do is find our z-score. And that's where we're going to use our z transformation equation. So z equals, if you remember, x minus mu over standard deviation. So we have what we need. Z equals, the score we're looking for is 13. Our population mean is 12 divided by 2.3. If we calculate that out, we really should get, 0.4348. Okay, if you round appropriately, the 8 moves that 4 to a 5, which the 5 moves a 3 to a 4. So my z is actually 0.44 if I really want to be technical. Okay, so now we have our z. But now we need to find that proportion again. Remember, between the mean and z, remember we're looking for this area right here, specifically between the mean and z in your unit normal table. So, is what you're going to do is find your z of 0.44 in that column A, and you're going to move over and find area between mean and z. Now, you should get 0.1700. So here should be P equals 0.1700. Now, to actually get the percentile rank, we need to add that proportion to the 50% on the other side. So we're going to add our P's. P equals 0.50 for that, for specifically this half of the distribution here, which is 50%, which is equal to 0.50, we're going to add that plus 0.17, and that will equal, if you equal 0.67. Now, because we're asking for percentile rank, this should be stated as a percentage. So this actually equals 67 percentile rank. That would be your final answer for this one. That's how you work through to get a percentile rank using z-score with a raw score. Okay, let's try one other one. Okay, this one is asking, what's the proportion of memory recall scores that fall between 9 and 11? So on this one's a little bit tricky. So we're looking for a proportion, not a percentile rank, and now we're looking for the proportion between scores of 9 and 11. So again, draw that distribution. Very important. Locate the mean, because this will kind of give you an idea of where you're going with those scores. The mean is 12. Now, key is finding the proportion when it's something kind of offset like this. So we know that 11 is below 12, so here's that upper boundary, score of 11, and then we probably have 9 somewhere over here, okay? 9. So we're going to be looking specifically for z-scores for 9 and z-scores for 11, because we can't get a proportion without a z-score. So that means you're going to have two different equations. You're going to have a z for your score of 9, a z transformation for a score of 9, and a z transformation for a score 11. So I'm going to show you just what that looks like when it's plugged in. So z equals 9 minus 12 over 2.3, and then z equals 11 minus 12 divided by 2.3. Now mind you, we're going to be looking very specifically just for this proportion right here. We're not going to be looking for any more. So there's a little trick to this. So get those z-scores, and I'll show you what you should be getting. For the z equals 9 minus 12, we should be getting a negative 1.30. Okay? Now that makes sense because 9 is below 12, which is the mean, so it should be a negative z. And then we have a z of negative I got 0.435, negative 0.435, which could be rounded to negative 0.44. So these are the z locations, okay? So I'm going to put here z equals negative 1.30 and z equals negative 0.44. Okay? Now, the trick is to find that sliver. And we only have on our unit normal table areas between mean and z and areas beyond z and tel. So the method I'm going to do is I'm basically going to look for the area from the mean to this location and then the mean to this location, and then I'm going to subtract them, and that will give me just this area once I subtract them. So if you look in your unit normal table for 1.30 and between mean and z, that column B, between mean and z, you should get a proportion. P equals, I'm going to write it over here, P equals 0.4032 is what I'm looking at, 0.4032, and then for Z equals 0.44, I'm going to get P equals 0.1700. Okay? Remember, these are positives, even though proportion is always positive, even though your Z's are negative. Those are just telling you where to look. Once I get those two, I'm going to subtract. So I'm going to subtract P equals 0.4032, and I'm going to take 0.1700 from that, so subtract that, and I'm going to get 0.2332. That should be your final answer, or 0.23. That is the proportion that you will find in that sliver between the scores of 9 and 11. That is the proportion of scores that you will find there. Now, I've wrapped up how to go through and find proportion, find using raw scores, z-scores, or finding proportion using raw scores and z-scores. You're going to practice with your homework. Now make sure for your homework problems, anytime you're dealing with probability, proportion, percentile rank within a distribution, you need to draw it to determine it. Draw that to determine it. And basically, when you're done, it should be looking like the ones that I've been drawing. So you should start with your distribution drawn and then locate things. It's very easy to mix up proportions if you don't draw it. It's difficult to picture it in your mind sometimes. So I'll wrap this up and you practice with your homework.